Let me introduce our next keynote speaker. His name is Revannth Narmatha. He is the CEO of Carbon Performance.
So I'm going to go over our additive manufacturing journey and how we sort of see additive manufacturing play an important role both in the thing of the past, which is internal combustion engines, and also the thing of the future, which I think we all can agree is purely electric and self-driving. And that's one of the interesting spaces that we see additive manufacturing add a lot of value. And yeah, how we sort of combine additive manufacturing with artificial intelligence, Internet of Things, and blockchain technology as well. That could be quite interesting. So it's just generalized in a structure. There's no clear agenda as to what my speech is going to be, but it's an overall overview of carbon performance, I reckon. So Carbon Performance was founded in 2018, so we are, so before, it's a relatively new company. We are based in Leeds, north of England. We are part of the University of Leeds' enterprise program. We offer solution especially for smart cities, autonomous mobility, vertical farming, renewable energy, shared, circular, on-demand economy as well. And so we're quite focused on the fourth industrial revolution. So the entire company is built from the ground scratch for the fourth industrial revolution, if you will. And we're also backed by different government bodies in the UK, and of course Siemens as well. So this slide will give you a gist of what our additive manufacturing journey has been so far. It's been a nightmare. That's what I would call it. It's a nightmare in the sense that it's a roller coaster ride combined with a horror movie. We had no idea what we're getting into. And of course HP is here, and they're quite world leaders in 2D manufacturing, as 2D printing. That's pretty much what we thought. You select a file, click print, and it prints a functionally beautiful part, but why we were wrong. So as Christoph mentioned as well, it's a really, really steep learning curve for us. It took 6 months for us to actually get our head around optimizing parts for 3D printing. One of the common misconceptions of 3D printing, of course, is you just 3D print stuff, but it's called digital manufacturing for a reason. 99% of what 3D printing is digital, and only 1% is in manufacturing. So the core aspects should be focused on design for additive manufacturing and not just the hardware manufacturing part of things. So our journey has been we've pivoted quite often in the last 18 months. A bit of a background about myself. I am a former motorsport racer. I was into motorcycle racing for the last 6, 7 years until I met with an accident. So we started off with low volume, high value aftermarket components for motorcycles, and we specifically did composites and thermoplastics. We then moved on to light sports cars, likes of Lotus, etc., etc. And we moved on to super sports applications in high performance motorsports, and also advanced applications in terms of Porsche and Ferrari as well. Where we are right now is we've pivoted quite often in a sense that we are a full-fledged mobility tech company focusing exclusively on electric and self-driving transportation. So that's pretty much our first project, really. This is, I think, back in March of last year. So we had this opportunity to design, optimize, and manufacture a Ducati Supersports motorcycle brake lever and clutch lever as well. And of course, we are quite new to 3D printing. We didn't know what we were doing. All we managed to do was, use third-party softwares to optimize the part for 3D printing. And we managed to get the weight of the part by 60% down. And we 3D printed it in thermoplastics with reinforcement of the carbon fiber. It was a success. You know how startups work. We delivered a single successful project, and this is how we felt. Yeah, it didn't last really long, and we were back to square one when we got into metal 3D printing, which was a whole another story of a nightmare. We had an opportunity to work with Lotus, and we were tasked with developing and optimizing a suspension part for a Lotus Elise car. I'm not sure how many of you in the audience are a big fan of Elise, but being a petrol head, I am a part of the cult behind Lotus Elise. And this is pretty much the time we started developing our very own in-house optimization software called Skeleton, which I'll get into later. The result was this. We managed to reduce the part's weight by 30%, and we improved its stiffness by 20%. And the best part was we combined 9 different parts into a single component. So the suspension part was really bulky. We made it much more compact. We saved a lot of space along with weight and cost as well. And here's another failure. So we integrated QR code, but what we didn't know was QR code needed contrast to function. So that was a big, big failure for us. We didn't really work. What we are experimenting right now is we are trying a lot of RFID tags to in the place of 3D printing. So yeah, the result was this. It was so functionally beautiful suspension uprights that I couldn't really stop looking at. In fact, so the guys in the office, we actually spent an entire night just looking at the part on a pedestal. It was just absolutely beautiful. Yeah. So with a teeny tiny bit of confidence that we had the last two projects, we wanted to do something that's really disruptive. And of course, earlier you saw Bugatti titanium brake calipers, and we wanted to do something different that Bugatti didn't do. We wanted to get into the aftermarket industry, especially for high-end automotive applications, the guys who own Lamborghini, Ferraris, and Porsche. And the brake caliper we designed was optimized by our in-house software called Skeleton. And best part was we offered mass customization, as David mentioned as well. And we 3D printed them in titanium, and the weight of the part was down by 36, 38% as well. The best part was, apart from aesthetics, we were able to tailor the stiffness, the drive feel, the braking performance as well. So every single brake caliper that came out of the printer was much more different than the previous one. So that's quite interesting for us to work with. It was quite a bit of a fun project, really. So we benchmarked the lightest caliper that ever existed in the market, which I'm not going to name the company. I don't want to get into trouble. They sold the caliper for £37,000, which, again, it's a lot of money. We managed to get it 3D printed, way lesser cost, way lesser weight, and most importantly, way lesser carbon emissions and carbon dioxide and energy as well. That's another project we did along with the OEM. I had to blur the logo on the part because, yeah, I don't want to get into trouble again. So that was for a Ferrari, and it's also adaptable for a Porsche 911 GT3. If you closely look at the parts, they look a lot like human heart. The reason is, as mentioned before, our software's name is Skeleton. The name Skeleton comes from a human body. We literally took inspiration from the human ribcage, the way your heart, your lungs are packed, so compact, yet you have so much space to operate as well. So all these thin elements you see are sort of like your ventricles and arteries existing in a human part. The best part was that the brake caliper was, I think, 58% lightweight, and we managed to combine 16 different parts into a single one. So that was quite interesting to work with. Here's a couple of examples we sort of played around with. So all these iterations of brake calipers we went through when we were developing our own software. So it ranged from your Volkswagen Passat all the way till a Ferrari 812. So we worked on quite a lot of different applications. So here's another application as well. So all these different brake calipers were sort of things of the past. They were specifically focused for gas guzzling, petrol and diesel cars, which I think we all can agree it's going to be the thing of the past. So we want to sort of morph ourselves into a future mobility company. And of course, I understand the name carbon performance could be quite confusing. A lot of people think we work on carbon fiber. Can't really blame them. So that's the opportunity that we're actually aiming for, really. It's a $2 trillion pie, and that we want to get a share of. And if you see the exponential growth, as David mentioned as well, it's quite interesting to work in the self-driving auto space, which is growing at 37% per annum. And that's pretty much where we want to be, especially in the 2.3 billion automotive 3D printing market. And mind you, that includes rapid prototyping, including production parts as well. But if you see the statistics, it's 97% rapid prototyping, only 3% is end-use production parts. Of that 3%, it's mostly thermoplastics and plastics, but it's not so much to do with metal. And we're trying to change that perception. So, as mentioned before, we want to get into electric cars. We thought, let's focus on a Tesla Model 3, which launched back then. And we managed to, of course, one of the really core obstacles for the adoption of electric transportation, I think we all can agree, is range anxiety. What if your car stops before you need another charge? And the significant effects of lightweightness has to be, it's sort of underestimated right at this point in time. So we managed to get the weight of the caliper really down, so we have 16 kilometers extra range per charge, which is quite significant when you compare it to a Model 3's range capacity. And that was quite interesting. And the best part, again, with combining different automotive parts together, you can actually make the car much more compact, so you don't need to have your gigantic, bulky cars. You can have your smaller urban mobility cars. So that could be quite interesting. And a lot of people, of course, focus on electric cars as being zero emissions, but that's not really the truth because you still need a lot of energy and carbon dioxide emissions to manufacture the car. And with 3D printing, you can actually get down the carbon emissions and energy so down you could have sustainability in manufacturing as well. So you have this holistic approach to sustainability rather than just focusing on the tailpipe exhaust emissions. I am going to be mindful of the time, so I'm just going to skim over things. So we see additive manufacturing, at least in the future mobility space, especially in electric and self-driving car space. We don't see 3D printing as being this standalone individual technology, but rather being an augmented technology to AI, IoT, and blockchain. So I've mentioned about our software before. We use deep learning to optimize the components. We call it skeleton for a reason because we generate hard points of a different automotive parts, and we then just fill in the flesh, just like human body. And we base sensors, IoT sensors, as the constraints, and we exactly grow the organic flesh around the parts, so you have this really compact, yet so lightweight components. And the third one is really, really interesting because it's blockchain. What exactly is the financial technology doing in 3D printing? I'm going to come back to that later in the 6 slides to come. So we did what we called connected components. It's quite a fancy name. So essentially what it requires, at least useful for autonomous driving, is you can offer predictive maintenance. So you can know different settings of the part itself. You can sell life cycles. In fact, the suspension uprights we did, we could actually monitor the life cycles the upright went through. So you can actually determine an expiration date. You walk into a Sainsbury's supermarket, etc., and you have this expiration date, and it's exactly what we envisioned with 3D printing and IoT. I'm going to run out of time. I'm going to skim over really quick. We use blockchain, of course. It's a really gigantic issue. Fake auto parts, it's 28 billion every year lost to automakers, and it's the 7th largest source of death in the UK. And what we essentially do is we use blockchain to have the trace of the entire journey of a single auto part, so consumers and organizations can actually find the trace and be confident in buying a 3D printed auto part, apart from the functionalities of it as well. So here's another example of how our blockchain actually works. It's still in infant stages. It's not really advanced. We will look to commercialize it next July. So you can determine if an automotive part is fake, if you cannot trust your third-party supplier. You can input blockchain as well to entrust in a confidentiality. So that's a really good application as well. I've got a really perfect time. So our website is currently down. We're going through a bit of rebranding and restructuring. But if you've got any questions, I'm going to be on the stage, or I'm going to be around in the booth. So please come and say hi. Thanks for listening.